accepted it because you felt that your domain experience says that you can take that level of risk. If you continuously keep doing this, 0.8, 0.82, 0.79, so on, or 0.079, sorry, that means the machine algorithm will accept that, okay, you are the level of your risk tolerance level is pretty high, and it will move the alpha level to a much higher level, which could be 0.085 or something like that. So that's what supervised algorithm works. It is basically a kind of a teacher teaching a concept to the student. Unsupervised machine learning is more closely aligned with what some people call is the true artificial intelligence. It is typically data being used to derive those insights. So supervised learning, regression is part of it, which we covered earlier. And unsupervised learning, we covered association as part of correlation and a priori algorithms. So let's look at the classification and clustering as part of machine learning now. Okay, classification. So what is that? So it basically takes the data sets and puts them into two classes. Those classes could be by class, for example, whether it's a person is the gender of the person, or whether it's an email is a spam or not, and so on. The multi-class, there could be multi-classes. Like for example, I have 5 different classes saying that if the asset is performing like this, the risk of this asset is pretty high, then medium, then low, or super low, or so on. So you know those classes, and you are trying to put those data object into those respective classes. So if you to create classes, you use those clustering, which is the next topic which we are going to talk now. So there are many types of classification algorithms. We discussed logistic regression a few minutes back. But the most important, the popular one is the support vector machines. Of course, there's decision trees and nearest neighbor. Let's see how the support vector machine learning algorithm looks like. So it's basically you look at good quality data, you put it into your algorithm, then the data says, okay, this is part of class 1, class 2, class 3, and so on. So the bottom line is the classes are predefined. You already know for sure. These are the 4 buckets which I have. And the support vector machine, what it does is it takes the data sets, and its job is to assign that element into one of these 4 classes. That's exactly what it does. How does this do? It does it by classifying the data into something known as the hyperplane. So hyperplane basically splits the data sets into whatever classes you have. If you have 2 classes, it splits it into 2. If you have 4, it splits it into 4 different classes based on the data points which are going to define the widest margin which is separating those 2 or 3 or 4 groups. So let's take a simple example to understand this. So you have defined 2 classes of vendors for NTPC. One is somebody known as good vendor, another class is known as the bad vendor. So you just have 2 classes here. These are classed based on 2 attributes. One is the delivery time, and next number 2 is the quality of goods supply. Now I have a new data point which is coming, or a new vendor who is called Precision Incorporated who is coming, who has a delivery score of 4.4 and a quality of goods supplied score of 5.7. Now I want to know, is Precision Incorporated a good vendor or a bad vendor? So these are the 10 data points I have, and as I said before, I have the 11th vendor coming. I want to see whether he is a good vendor or a bad vendor. So he has got 2 attributes, 4.4 for the time, delivery time, and 5.7 for the quality of goods supplied. Let's assume that I'm looking at 4.4 and say, oh, for the vendor number 1, he has a delivery score of 4, so that means he can be a good vendor. But if I look at row number 6, it has got 4.5. But even if it is 4.5, also he could be ending up as a bad vendor. So that means I need a different ways of classifying this. So imagine you are in a situation where you have 1,000 vendors, and you have 25 attributes for those classifying the vendors. and you have 10 different classes. So this becomes very complex to manage. That's why you rely on those machines to do an appropriate classification. But for demonstration, I have taken a very simple case where we have just 2 classes defined based on just 2 attributes. The first step is to get the data and make sure that the vendors are classified into a good vendor or a bad vendor. Then you define what is known as a hyperplane. And this is where concepts such as the matrix algebra, the matrices, and all those things which we discussed in the second class comes into the picture. So use your matrix operations and come up with this linear equation, which is y is equal to mx plus b. And based on this, and you calculate what is the offset as well. And this line is known as the hyperplane, which is basically what's going to define the 2 groups. So in this case, you can see that the red dots are the bad vendors and the blue dots are the good vendors. And this hyperplane splits the entire data set which you have defined in this 2-dimensional plane, which is delivery versus quality, into those 2 classes. If you have 4 dimensions, it becomes very difficult. It doesn't, you can't plot it like this. It becomes a 4-dimensional object, but still an hyperplane is just there, which is going to cut the data points into n number of classes. That n can be 2, 3, 4, whatever the classes which you have. Like if you are in a procurement world, like SAP for example, you have something called material groups or asset groups which you have. So you classify the asset into in most of the companies I have seen, hundreds of groups which you want to classify, which is basically classes. Now, if a new asset is coming, you want to see whether it belongs to which asset group does it belong to. So once you have this hyperplane equation, you take your precision incorporated vendor and put it into this equation, y is equal to mx plus c. So you have this vendor with delivery score as 4.4 and the quality score as 5.7, and you put it into this equation and you have a very low score of minus 12.7. And in this case, in step 2, we define anything lower than minus 1 is a bad vendor, anything more than plus 1 is a good vendor. So we are going to classify the precision incorporated as a bad vendor in this case. The second part of machine learning algorithms is known as the clustering. So in clustering, what we do is we assign those observations into subset known as clusters based on some homogeneous conditions. We find some